Hello everyone, I'm Brad Breckenridge, filling in for Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
We begin with a look at a fascinating moon called Titan, which is orbiting around the planet Saturn. This moon has become the subject of much scientific speculation in recent years, since it was discovered to have an atmosphere roughly 4 times thicker than Earth's. About half the size of Earth, this small planet-like moon has an atmosphere that contains large amounts of nitrogen and carbon. This is important because these chemicals are considered by many scientists to be the building blocks for life as we know it.
Little is known about Titan's surface because its thick atmosphere hides it from view. To help us learn more about Titan, NASA scientists have launched an intriguing mission to explore this distant moon. This mission, called Cassini-Huygens, was launched from Kennedy Space Center on October 15, 1997. Once at Saturn, the Cassini-Huygens spacecraft will not only study Saturn's atmosphere and its other moons, but will also drop a small lander onto the surface of Titan. While Cassini-Huygens will dramatically boost our knowledge of Titan, it will likely lead to more questions about this interesting moon.
Tonya St. Romain spoke with researcher Dr. Marianne Rudisill to find out more about the current mission and possible future missions to Titan.
One of NASA's stated goals is to search for life and life-enabling conditions such as water and lifelike chemistry throughout the universe. In recent years, the task of searching for life has become much easier with the development of tools like the Hubble Space Telescope and advanced sensors aboard spacecraft. With these technology advancements, NASA scientists are now able to better identify so-called hotspot locations in the universe. A hotspot location is simply a celestial body, that is, a planet or a moon, that may have conditions that are conducive to the origin and existence of life. Scientists have located a number of potential hotspots in our solar system, but one of the most intriguing is a moon orbiting the planet Saturn named Titan. Titan is very exciting because unlike most moons in our solar system, it actually has an atmosphere. In fact, many scientists believe that Titan's atmosphere closely resembles early Earth's atmosphere 3.5 billion years ago, when life was just beginning on our planet. The chemicals that make up Titan's thick, hazy atmosphere include nitrogen and carbon, elements considered by scientists to be the building blocks or raw materials for life as we know it.
With this in mind, NASA and European Space Agency scientists are working on a mission called Cassini-Huygens, which will study Saturn and some of its moons, including Titan. The Huygens probe will descend into the thick Titan atmosphere to study its composition and look for signs of prebiotic chemistry. I spoke with Dr. Marianne Rudisill at NASA Langley Research Center to find out why this distant moon is such an important place to study.
Titan's a really interesting place to explore for a number of reasons. It's a very large moon. It's larger than 2 of our planets, Mercury and Pluto. But the most interesting thing about it actually is that Titan has a very dense atmosphere. And this atmosphere has a lot of chemistry, interesting chemistry going on. Most of the atmosphere at Titan is nitrogen, a lot like Earth's. It has methane, but it also has a lot of complex organic types of molecules going on. And it has weather as well, and so we think that potentially there are actually clouds on Titan that kind of rain organic molecules down onto the surface and kind of lay out an organic sludge along the surface of Titan. So a lot of scientists believe that in some important ways Titan might actually be very much like what Earth was like in its early days prior to life on our planet. So it's an interesting place to go to kind of look at those processes and understand how life originated on our planet in that type of physical environment.
One of the reasons Titan is of great interest to scientists is because it's the only moon in the solar system known to have clouds and a thick planet-like atmosphere.
Because Titan's atmosphere contains nitrogen and high percentages of smog-like chemicals such as methane and ethane, it may actually rain gasoline-like liquids onto the surface, forming shallow methane-filled lakes. Although the smog-like atmosphere would be harmful to humans and other forms of complex life on our planet, the organic nature of Titan's atmosphere is much like the prebiotic environment from which life arose here on Earth. Simply put, these conditions may actually be laying the foundation for life on Titan sometime in the future. Dr. Urticell, is there potential for life on Titan?
Well, that's a really interesting question, actually, and maybe yes and maybe no. And I say that because of this. Maybe yes, because Titan has, as I said, some really interesting and complex organic chemistry going on. But the problem is that chemistry isn't all that it takes to have life. Titan is very far away from our sun, and so it's a very, very cold place. So the problem is that everything is ice. And life as we know it needs access to liquid water. And it also needs a source of energy. So on the one hand, yes, the chemistry could potentially support early life on Titan, but it's not warm enough. It's too cold and it doesn't have access to water and energy that it would need. But you could speculate about some other ways perhaps that it could have liquid water. We know, for example, that meteorites have come to Titan and hit the surface, generating heat and bringing energy with it, and perhaps for certain amounts of time, then that would mean that there could be pools of liquid water there. So it's really interesting to think about and speculate about the possibility of life and other parts and other locations of our solar system, and Titan is a very interesting place to look into those questions, and that's why we're going there.
Once the spacecraft gets to Saturn, how will it collect data? Will it use rovers like the Mars rovers?
No, actually, it's going to be rather different from the Mars mission. We're not sending rovers like Spirit and Opportunity. It won't be trundling around on the surface like we did on Mars. First, we're sending the Cassini spacecraft, and it's an orbiter, and when it reaches Saturn, it'll actually spend the next 4 years there, kind of doing a grand tour through the Saturn system. And one of the things it will do is about 40 flybys near Titan, collect information, kind of a big picture view of Titan. But then in addition to that, we have a Titan probe, Huygens probe, and that was developed by the European Space Agency, and it'll drop down through Titan's dense atmosphere and all the way down. The instruments will be taking all kinds of measurements like the density of the atmosphere and the temperature and altitude and things of that sort. And of course, it's going to be taking a lot of data, a lot of information about the chemistry of Titan's atmosphere, what kinds of things are there and how much. And it'll take about 2 to 2.5 hours to get all the way down through the dense atmosphere. We don't know what it will land in, but it will be able to stay on the surface and then in its local area kind of take some measurements and also radio that information back to the orbiter and back to Earth.
The next generation of science missions to Titan will probably be much different than the missions of today. Because little is known about the moon's geology, one type of mission concept recently developed by NASA would rely on a dirigible type craft to move through Titan's atmosphere, taking multiple measurements over time. This blimp would float above the surface and deploy a small probe to sample Titan's atmosphere, methane crater lakes, and crater rim ice. The probe would be able to analyze the samples on the spot and then relay the information to scientists back on Earth. With Earth nearly 800 million miles away, the probe would need to be almost completely autonomous. This type of craft could conceivably float through Titan's atmosphere for many months, gathering valuable evidence about Titan's chemistry and geology and what that means for us back on Earth. Realistically, what are your expectations? Are you expecting to find life on Titan?
Scientists try to be very objective, you know, and only have attitudes and opinions based upon what we know, of course. And so I think a lot of people are holding back and saying, I don't expect to find life there. It's too cold. Even though we have extremophiles here on our planet that can live in very dry or very cold conditions, it's really cold out there, you know, and there isn't liquid water. So we're not expecting to see anything there. But the nice thing would be is if we could find, I think a lot of people would be very, very happy if we saw some serious complex organic chemistry going on. Prebiotic, you know, clearly prebiotic chemistry would just be wonderful. Going to other destinations in our solar system and then gathering this kind of information could really help us understand how our planet formed and how life originated on our planet. And these are really profound questions, not just to scientists, but to everyone. And so I think it's really interesting and great that NASA can send spacecraft and gather these kinds of data to help us answer those kinds of questions.
Many astrobiologists are skeptical as to whether life as we know it exists on Titan. Although many of the building blocks for life are there, temperatures average a numbing -290 degrees Fahrenheit. However, Titan might provide a habitat for life if scattered sources of heat from geysers or volcanoes are discovered. Coming up, we'll find out how NASA has been using a technique called aerobraking to insert spacecraft into extraplanetary orbits. But first, did you know that Saturn's density is the lowest in the solar system? Although Saturn has a diameter of about 75,000 miles, it's made up of primarily hydrogen and helium gases. The presence of these gases makes Saturn's specific gravity at about 0.7, less than that of water. In fact, Saturn's density is so low that if it were placed in an imaginary gigantic bathtub, it would float.